Assalamu alaikum dear students. We are solving the problems or the statements through mathematical induction, and today we are going to solve question number 5 of this exercise, which is we have to prove that for all n belongs to natural numbers 1 into 3 plus 2 into 3 square plus so on to n into 3 raised to n is 2n minus 1 into 3 raised to power n plus 1 plus 3 upon 4. We have to prove this that this statement is true for all n. Now let p of n equals to 1 into 3 plus 2 into 3 square plus so on to n into 3 raised to power n. That is given statement. We have to prove that for all n, p of n is 2n minus 1 into 3 raised to power n plus 1 plus 3 upon 4. So we have to prove this. Now here the given statement contains n, so we will use here the mathematical induction. Now for mathematical induction we prove the result for the smaller values of n. Now for n equals to 1, p of 1 is simply first term of this sum, that is 1 into 3, which is simply 1, and LH or HS of this is 2n minus 1 into 3 raised to power n plus 1 plus 3 upon 4 is simply by putting n equals to 1, which is after simplification simply 12 upon 4, that is 3. So this means that for n equals to 1, p of n is true statement. That is p of n for n equals to 1 is 2n minus 1 3 raised to power n plus 1 plus 3 upon 4. Now let's assume that this statement p of n is true for n equals to k, that is p of k is 1 into 3 plus 2 into 3 square plus so on to k into 3 raised to power k is 2k minus 1 into 3 raised to power k plus 1 plus 3 upon 4. Now here we shall prove this statement, that this p of n for n equals to k plus 1. Here p of k plus 1 is 1 into 3, 2 into 3 square plus so on to k into 3k, which is up to k, and for k plus 1 it is k plus 1 into 3 raised to power k plus 1. Now by assumption we assume that p of k is true for n equals to k. This means that the sum of these first k terms is 2k minus 1, 3k plus raised to power k plus 1 plus 3 upon 4 plus this last term, that is k plus 1 into 3 raised to power k plus 1. Now here this 3 is independent of k and its denominator is 4. So here we write this as plus 3 upon 4. Now this term and this term, they contains 3 raised to power k plus 1 term, so taking 3 raised to power k plus 1 common, and 4 is in denominator, taking this also common. Here we are left with only 2k minus 1 and k plus 1 into 4, because 4 is in denominator, which is simply 6k plus 3. Taking 3 common, it is simply 3 raised to power k plus 1 plus 1, because we are taking 1 3 from this. It is simply 2k plus 1 upon 4 plus 3. Now this 2k plus 1 can be written as 2k plus 1 minus 1, because 2k and 2 into k plus 1 minus 1 is simply 2k plus 1 into 3 raised to power k plus 1 plus 1, now plus 3 upon 4. Now clearly this is of the form of k plus 1, because in here in the given statement, which is 2n minus 1, here we have 2k plus 1 minus 1. 3 raised to power n plus 1, here we have 3 raised to power k plus 1 plus 3 upon 4. So this means that this statement is also true for n equals to k plus 1. Hence by induction we can say that this statement 1 into 3 plus 2 into 3 square plus so on to n into 3 raised to power n is 2n minus 1 into 3 raised to power n plus 1 plus 3 upon 4 is true for each and every n. Now from question number 6 to up to 11 you can use the same procedure, and these are the home assignments for you. Now the question number 12 is we have to prove that a plus ar square up to a raised to a into r raised to power n minus 1 is a into r raised to power n minus 1 upon r minus 1. where a is some fixed number. Now let here the given statement, that is we have to prove that this equals to this. Now given statement contains n, so we shall here use the principle of mathematical induction. Let p of n is a plus a r plus a r square plus so on to a r raised to power n minus 1. That is we have to prove that p of n is a or raised to power n minus 1 upon r minus 1. Now for n equals to 1, because in induction we prove the result for firstly for the smaller values, then we assume that for any arbitrary value, then we prove for its successor. This is a procedure of mathematical induction. Here for n equals to 1, p of 1 is simply a means first term, and a r is power n minus 1 upon r minus 1 is simply a r minus 1 upon r minus 1, cancelling r minus 1, that is a. So this means that for n equals to 1, statement is true. Let's assume that the statement is true for n equals to k, that is p of n is true. That is p of k is ar square plus ar square plus so on to a or k minus 1 is a into r raised power k minus 1 upon r minus 1. Here we have r minus 1. It is r minus 1 here. Now we shall prove this for n equals to k plus 1. Now p of k plus 1 becomes a plus ar square plus so on to a or k minus 1 plus a or k. Because here up to n terms we have r raised to power n minus 1, so this means that for k plus 1 terms, here last term should be a or k, simply a or k, because one less from the given number. Now by assumption it is true for n equals to k, so this means that the sum of the first k terms is a into r k minus 1 upon r minus 1. Now the last term is a or k. Now taking a common, so we are left with a r raised to power k minus 1 upon r minus 1 plus r k. Now by cross multiplication, this r raised to power k and minus r k cancels, so we get here a into r k plus 1 minus 1 upon r minus 1, which is same of the form of a r raised to power n minus 1 upon r minus 1. Because here for n terms this power of r is n. Here for k plus 1 terms we proved that the power of r is also k plus 1. So this means that the statement is also true for n equals to k plus 1. Hence by principle of mathematical induction, p of n is true statement for all n, that is p of n is, which is a plus ar square plus so on to a or n minus 1 is a into r is power n minus 1 upon r minus 1. Similarly, you can solve questions question number 13 up to 17 by the same procedure. Now the question number 18 is we have to prove that 1 plus 2 plus up to n, that is sum of the first n numbers, is less than 1 upon 8 into 2n plus 1 ka whole square. Here let p of n is the given statement, that is sum of the first n numbers. We have to prove that this sum is less than 1 upon 8 into 2n plus 1 ka whole square for all n. Now by induction for n equals to 1, p of 1 is simply sum of the first number, and 1 upon 8 into 2n plus 1 whole square is simply by putting n equals to 1, which is 1 upon 8, 2 into 1 plus 1 whole square, which is 9 by 8. Now denominator of this is less than the numerator, so this means that its value is greater than 1, or we can say that 1 is less than 9 by 8. But p of 1 is here 1, which implies that p of 1 is less than 9 by 8 or is less than simply 1. So this means that the given statement is true for n equals to 1. Now let's assume that for n equals to k, p of n is true, that is p of k is sum of the first k numbers, which is less than 1 upon a into 2k plus 1 square. Now we shall prove for n equals to k plus 1. Now p of k plus 1 is sum of the first k plus 1 numbers, which is 1 plus 2 plus 3 plus k plus 1. Now here sum of the first k numbers by assumption is less than 1 upon a 2k plus 1 whole square. So this means that this sum of these two numbers, one the first first term is sum of the first k numbers, and next term is the next number. Now clearly this is less than 1 upon 8 into 2k plus 1 whole square plus last term, which is k plus 1. Now here this term, this whole term is simply 2k plus 1 square plus 8k plus 8 upon 8. Now breaking this square, we after simplification we simply get 4k square plus 12k plus 9 upon 8. Now this 4k square plus 12k plus 9 is simply 2k plus 3 ka square upon 8. So this means that this term is simply 2 into k plus 1 whole square upon a, because 8, because 2k plus 2 plus 1 is simply 2k plus 3. But this term is less than is greater than p of k plus 1, which implies that p of k plus 1 is less than 2 into k plus 1 ka whole square upon 8. So here this k plus 1, in the given statement we have up to sum of the first n numbers contains n. So sum of first k numbers here also contains k plus 1. So this means that by induction the given statement is true for each and every n. Hence, by the principle of mathematical induction, the sum of first n numbers, natural numbers, is less than 1 upon 8 into 2n plus 1 whole square. So thank you.